So, we always talk about machines that can understand a story, right? Not just the individual words, but the whole story. Well, a huge part of that is a special kind of neural network that actually has a memory. But here's the kicker. What happens when that memory just fades away? That's what we're going to unpack today, this really critical flaw in recurrent neural networks and why their memory can sometimes vanish into thin air.
Okay, so before we get into why this memory fades, we've got to understand what makes these networks, we call them RNNs, so special to begin with. Let's take a look at what they're all about. All right, check out this table. It really breaks it down perfectly. On one side, you've got your standard feed-forward network, no memory. But on the other side, that's our RNN. See that? It has memory, using these things called hidden states. That's its superpower, really. But, and this is a big but, look at the trade-off, right there. Gradient issues. That's the catch. RNNs can suffer from something called vanishing gradients, and that's exactly what we're going to get into.
And here you can see it visually. The network on the left, that's like a one-way street. Information just flows straight through. But the RNN on the right, that's where things get interesting. You see those loops? That's the magic right there. It means information can actually loop back on itself, giving the network a way to remember what it just processed. That loop is its memory. So when you give an RNN a sequence, like a sentence, it kind of unrolls itself through time, just like you see here. It processes the first word, then the second, then the third, and at each step, it's passing along what it remembers from the step before. It creates this long chain of operations. And this chain is what gives it its power. But you guessed it, it's also the source of its biggest weakness.
Okay, let's get right to the heart of it. We've seen this long chain. Now let's talk about why it's so fragile. It's time to put a name to the problem, the vanishing gradient.
Yeah, the source material is super direct about this. It says, flat out, that RNNs are known to have issues with this vanishing gradient problem. It's like their Achilles heel. But what in the world does that actually mean? How can a gradient just vanish? And why is that such a disaster for learning? All right, let's break this down. The gradient is basically the learning signal. Think of it like this. When the network makes a mistake at the end of the sentence, it sends a correction signal backward through that chain we saw. It's basically telling all the previous steps, hey, you guys messed up, you need to adjust. But here's the problem. As that signal travels backward through all those layers, it gets weaker and weaker and weaker. It shrinks until it's practically zero.
So, you see what's happening? This isn't just some abstract math problem. When that gradient, that learning signal, disappears, it has a very real consequence. What's really happening is the network's memory is literally fading away.
You know what it's like? It's like that game of telephone you played as a kid. The first person says something clear, but by the time it gets passed down the line, the message is a garbled mess, or it's gone completely. That's exactly what's happening here. The important information from the beginning of the sequence, that's the original message. But by the time the network needs to learn from it, the signal is just too weak to make a difference.
The source actually has a perfect way of describing this. It says the gradient attenuates dramatically. I love that phrase. It fades away. It gets so faint. And the result is that the network simply cannot make a connection between what's happening now and something important that happened way back at the start. That crucial link is just gone. The chain of memory is broken. So what does this actually mean in practice? Well, it means the network gets really, really bad at learning long-term patterns. The key piece of information might be in the first sentence of a paragraph, but by the time the network gets to the last sentence, it's completely forgotten it. That powerful memory we were so excited about, it becomes effectively short-term. It's so frustrating.
And this comparison just lays it all bare. For things that just happened, the later time steps, the learning signal is strong, the memory is fresh, everything works great. But for anything that happened earlier on, the gradient has vanished, the learning is minimal or non-existent. It's like the beginning of the story just gets completely erased from its memory.
And look, this fundamental weakness is precisely why researchers had to go back to the drawing board and invent whole new architectures. But it really leaves you with a big question, doesn't it? If an RNN's memory of the past just fades away, how can it ever truly understand the whole story? How can it grasp the kind of deep, long-term context that we humans rely on every single day? That's the challenge, and it's one that really gets to the core of what it means to build an intelligent machine.